Hey, what's up? I'm Jason, and today I'm going to show you a technique that I like to use to clean up my code, keep my source files from getting too large, too out of hand, and also to keep my code unit testable and just working right. So here I've got an example set up where I have two different entities that want to fight each other. So imagine we're in a bigger game. In fact, this comes from an MMO example. We've got NPCs fighting players or other NPCs, and they want to know when they should attack each other, and we want to separate out or be able to control their attack code a little bit better. So I'm going to show you the first example, which has all of the attack code kind of baked into the entity, and it's not super testable and it's not easy to adjust. So let me show you what that looks like first. We've got an entity here. So in fact, I've got two of them in my scene, entity 1 and entity 2. You see they both have 10 health. Entity 1 is targeting entity 2. So it's got the target set. If I click on it and just go to entity 2 and hit play, you'll see that my health doesn't change at all. So nothing's happening. We don't take any damage or anything. And if I go to the script, you'll see, well, let's take a look at it. How does this work? We have an update method. We check to see if we should attack yet. So we're checking to see if the next attack time is met. Since that's not set, this is going to pass right now. On the first run through, we're going to make it right past that. Then we check to see if attack on is false. We're defaulting it to true and we can't change it. So that's true. And that's not happening. We're not exiting out. That's basically just an exit. So if we turn off attack, we don't keep trying to process our attack. If we don't have a target, we return. We have a target here. And then we do a distance check. So we check to see the distance from ourselves to the target, and we check to see if that's greater than the attack range. If we do, then we exit out. And if we look here, you see our attack range is 1. So that's why it's exiting out and not taking any damage. Let's move them a little bit closer. We get a little bit closer and we see that now it's taking damage. It goes 9, 8, 7, 6. We're losing about 1 a second. And I think if we go back into that script, you'll see that it's because our attack delay is actually, it's at 2 seconds. So we're losing 1 every 2 seconds. I said 1 a second because I can't keep track of time very well. So let's see what it does then. So if it's in range, we call do attack. We reset that attack time with the 2-second attack delay, and then we tell the thing to take damage. So this code all kind of works. It's functional, but it was going to get a lot more complex. In fact, in a real world example, the number of checks that we do it's a whole lot more than just 3 little checks. We have to check all kinds of things to make sure that the target is valid, that the player or the thing attacking is in a valid state where it actually can attack. There are quite a few different things that we need to take into account. And our do attack code would generally be a lot more complicated too. It's not just going to say, hey, take this amount of damage. We're going to look at our weapons and do a whole bunch of stuff with that. And this is supposed to be in some entity class. So imagine we have a base character class that all of these things share that deal with combat. And then this is just a small part of that. In a real project, you may end up finding that this is like part of 5,000 or 10,000 or 100,000 lines of code for one giant monolithic class. And you want to split this stuff out. And that is what we're going to do. We're going to split this out. We're going to separate it so that it's testable and completely, I'd say, consumable. You can understand what it's doing without getting too confused. And we're going to do it really quickly, and I think it'll be a lot of fun. The end result will be much cleaner code and easier to manage project. So how would we do this? Well, let's take another look at this. We've got all of these properties here, and we have a little chunk of code. So this is really, like this chunk of code here in our update is really just checking to see if we can attack. So the first thing I would do here is just extract this out into something that just lets us know whether or not we can attack. Or, yeah, let's do that. So we'll take this and we select that chunk of code, and in Writer, I just hit Control-Shift-R and hit Extract Method. You can also hit Control Period and Extract Method in Visual Studio. And I'll just hit Enter, extract the method, and let's call this can attack. Or, no. This is actually not can attack. Cannot attack. So if cannot attack, we return. Otherwise, we attack. So notice how this already got a little bit easier to understand. Now we say if we can't attack, we return. Otherwise, we attack. Nice and simple. So what's the next step? Well, the next step is actually to make an actual class. So what I'm going to do here is go up to the top of the file, say public class auto attack controller, And then I'm going to take the cannot attack. I'm going to take the do attack, and I'm going to cut those and paste them right up into this auto attack controller. Now we've got a lot of errors, right? Now nothing works. It's red everywhere, all kinds of problems. What do we do? Let's fix it. So first thing we're going to do is take the next attack time and just move that up, because the attack controller, this is going to be an object that's just keeping control of auto attack for this one thing, and it's going to need access to its own timer. Now we've already pulled that out of the entity and separated it out, and shrunk the entity class a little bit, which is nice. But we still need access to a lot of other things. We need access to all of these properties that are on the entity. So how do we do that? We have a couple options. The easiest is to add a constructor to this auto attack controller. So to do that, I just go up here, line 7, just type CTOR, and then hit tab. That just generates a constructor. That again works in just about every editor that you can use. And then I want a parameter here. So I'm not going to have no parameter. Instead, I'm going to take an entity original and just call it entity original, whatever. And then we'll set the entity locally. So on line 9, I'll do underscore entity original equals entity original and create the field. There we go. So now we've got a reference to the entity that owns this auto attack controller. In fact, I'm going to rename this to owner. There we go. So the owner is now assigned in the auto attack controller when we create the auto attack controller. We haven't done that yet though. So let's do that next. And we can do that right here in our entity original. So what I'll do is go start and just generate a start method. Just typing the word start and hitting enter, I'll do that usually. That's definitely in Writer and usually in Visual Studio. And then in start, what I'm going to do is say underscore auto attack controller equals new auto attack controller. And then I'll pass in this. Then we hit Alt Enter and generate that field for the auto attack controller. Then in my update, instead of going through and calling cannot attack or do attack, I'm just going to call auto attack controller.tick. And we'll generate that method too. Then I'm going to cut out 61 through 64. Don't need them here. I've got them on my clipboard though, just in case I want them. And then hit Alt Enter to generate this tick method. So now we have an empty tick method. We have some uncalled code up here for cannot attack and do attack. And then we have the constructor. So first thing I want to do is just move this tick method up to the top, just because I want it to be in order. I want to be able to see what the class does and just read along from the top to bottom. So we'll know that it takes an owner and then it does some ticking. So here it's going to say if it can't attack, cannot attack, then we'll return. We don't need to do anything. Otherwise, we'll do attack. And now you might be wondering, well, what do? We don't have attack on. We don't have the transform position or this attack range. We've got an error here, and this auto completed and fixed something to graphics buffer. Let's delete that. I don't even know how that happened. Complete accident. It was trying to fix something for us, but it added in I think I hit the wrong hotkey. It added in a graphics buffer thing instead. So how do we get access to these? Well, we get access to these through the original owner, or this entity original that's the owner. So I'm going to copy owner and paste it down here. And then we drop it right before all three of those properties and this fourth property for the target. And we can even do it for the transform. Right? So we do owner.transform position, the target. Now we've got can not attack all figured out. This works because we have access to the owner and we can read all those properties on it. Now we can do the same on do attack. Just say owner.target and owner.attack delay. And it's no longer this.attack damage, it's owner.attack damage. So we're really close. Almost all of the errors are gone except for take damage. If I F12 to that, you see that take damage is throwing an error or showing an error. In fact, let's go back to it. Put the mouse over. Just because it's private and we're now in a separate class. It used to be fine because we were in the entity class. Now we're not, so we have to make this public. We want to call it from outside. All right. There we go. We've now successfully split it out. It's still not really testable though. It is separated. It's a little bit cleaner and I'll show it running real quick, but it's not completely separated. It's not completely testable yet. We still have another step or two to do. So first, let's move this into its own file. So to do that, I select the class by name right up here. And in Rider, it's just Alt-Enter. In Visual Studio, I think it's Control-, maybe Alt-Enter. I've lost track now. And then we hit move to whatever the file name is. And it's just going to give it its own file, matching the class name, and separate that out a little bit. So now we have this nice small, let's get rid of the extra space, this nice small auto attack class that I'll be able to test pretty soon. We can't quite test it yet, but we'll be able to test it soon. And then in our entity right here, we've shrunk things down quite a bit. Right? We've reduced at least a good chunk of code. We have more that we can remove. So let's go try this out. Let's jump back over to Unity. We'll stop playing because it's been running the whole time. And we'll hit play and just move closer and see if the health keeps going down like it should. There we go. Go back to the scene view, and if we move within a meter, yep, health starts dropping slowly, just like we would expect. Perfect. So everything's still working, but our code's a little bit more separated. So now we get to the fun part. Now I want to write some unit tests for it. So I've got, well, let's go to the solution right here. I've got an editor folder with a tests folder and an auto attack test file in it. And here I want to check a couple things. I want to do a test that makes sure that we don't attempt attacking when we don't have a target. I also want to test that we actually wait for our cooldown. Now, before we implement the wait for cooldown test, I just wanted to give a special thanks out to everybody who's been sharing my videos and liking and subscribing. I really appreciate it. If you got a chance right now, hit that share button, please. Also, special thanks to everybody on Patreon. You guys are awesome. I really do appreciate it. So let's get into this wait for cooldown method. We want to test that the auto attack controller is waiting for cooldown. Since it's split off of our entity, we can just test that auto attack controller object. So say auto, oops, I've got to click in there. Auto attack controller equals new auto attack controller. And remember, we require an entity for the owner. So I'm just going to pass in owner, but we don't actually have the ability to create an owner. So if I hit Alt-Enter and generate a local variable and then try to do like a owner equals new original entity, we're going to get a message here saying that we can't instantiate it that way because it's a game object. And we know that, right? We can't just create a new game object like that. We have to do new game object.add component or something. But I don't really want to test mono behaviors or game objects at all. We're in a regular unit test, not the play mode tests. We want to test against a mock of this or a substitute. We don't really care about the entity. We only care about testing the auto attack controller. Now we have an interface for it. So remember, we went in and created this iAuto attack. So what we're going to do is change this up just a little bit. So I'm going to just copy that interface and go back. And we're going to replace original or entity original here with iAuto attack. And we can't new that, right? So we're still not quite there. We're not going to be able to instantiate it. What we can do, however, is create a substitute for it. And to do that, we need a special framework called nsubstitute. It goes with nunit and allows us to mock and substitute things out really easily. Now, to install it, it's kind of a pain. It's not very clear and straightforward, at least not as of today's recording. Maybe this will change in the future. But right now, the process involves downloading nsubstitute. So you can just go to the GitHub page for nsubstitute, grab the latest version. I think I grabbed 4.2.1 there. Downloading that. And then open up the zip file, and you're going to go to a very weird location. Well, it may seem weird. You're going to go into the docs folder, then downloads, then look for nsubstitute 2.0.3.0, lib, dot, and then this net35. This is so that it works in Unity. And we need to take this nsubstitute DLL from, again, the .NET 3.5 version, and drop that in to your editor folder. So I've got plugins, editor, and oh, where did I put it? I thought I just put it into the oh yeah, right here. Sorry, I dragged it out. You're missing it. So we got to take that and put it into our editor folder. Now I don't see it here, so if I can't drop it in there, I should say. So this happens all the time, by the way. If you're in a zip file and you try to drop into Unity project, you can't. You can just right click, hit show in Explorer, go into that folder, and then I can just take the file here, copy it, and paste it. That usually works. Or I can just open this in a regular folder that's not a zip. It's because I'm in a zip that I can't do it. There we go. It should pull in my nsubstitute file. And if I select it, let's see. There we go. Everything should look pretty much just like this. The target should be .NET 3.5. We can leave this just checked on editor and leave everything else kind of as the default. Now let's jump back over to our code. So we can't do new auto attack, but what we can do now, since we have nsubstitute in, is say substitute. And I'm going to hit escape now, and then I'm going to hit Alt-Enter to add the using statement. And that's adding this using nsubstitute. So I have substitute, and then I do .for, and it takes a generic. So I hit F and hit Enter, and it really auto-completed. Then I need to give it the type. So I'll give it type of I auto attack. So it's going to give me a mock or a fake version of an I auto attack implementer that I can then use to pass into something. So our auto attack controller right now only takes, well, let's hit F12 and go to definition. It only takes an entity original, and I want this to actually take an I auto attack. Now that has broken this line 10, so we need to change the definition here on line 6 to also be the interface. So copy that and paste it up there. But now we have, well, look, no errors. We have an auto attack controller that still works, but it runs against an interface of an auto attacker or an interface of a thing that could auto attack. It doesn't necessarily have to be an entity anymore, which means that we can now mock that, inject it, and test very easily. So now we're able to pass that in and we don't have an error here. And here I can just say auto attack controller.tick. And that will run the code. So let's say we ran the code once and it ticked. It's going to say, well, can it attack? It's going to fail because of attack time. No, it'll actually pass because of attack time, right? It might fail because attack on is not true. And it might fail because the target is not set. Or it could fail because of the distance. And right now I'm not really checking the timer. I need to make sure that we actually get a successful attack. So I want to make sure that take damage is getting called on my target. So let's go back in and set up this test a little bit more. So I need a target. And I think I want to, well, let's set up our owner a little bit more first. So our owner needs to be auto attacking, right? For our code to run in here in our tick, auto attack needs to be set to true and our target needs to be set. So I'm going to set our owner's auto attack value first. So we do owner dot it's attack on, sorry, dot attack on, and I don't just say equals true. That's not normally the way I would do it. What I do instead is dot returns true. So whenever we check attack on, it's just going to return true. Now this is part of the nsubstitute library, so this is available because we have that substitution. We also want to set the target. So owner.target.returns, and we need some type of target. So I'm just going to make a variable named target, and then we'll implement it. So let's create a local variable. Now our target also wants to be an entity original because, well, that's how we set it up, right? We do things to an entity. Let's in fact go back into that tick or just into the auto attack controller and take a peek, right? So we call take damage on the target. And really all we care about is this right here, the target on the auto attack interface, because we don't really care about the implementation. So what we want to do is make an interface for things that can take damage. So I'm going to go back over to our entity and we're going to extract another interface. This interface will encompass our take damage method, maybe our health method, and that's probably about it. Probably the transform as well, I guess. So to do that, this time let's do it manually. I'm going to go down to the bottom of the file and I'll do public interface and I'll call this I take damage. We'll give it a take damage method. So to do that, I'm going to copy this. Just copy everything except for the word public. We don't put public or private in our interfaces. They're always public. That's kind of the idea. It's a public interface to things, so everything must be public. And we'll put in the health. So let's go to the definition for health, and I'll just take that and paste it right here. Notice, though, we don't need this private set, and it even gives us an error, again, because the interface only shows the public stuff. So now we have an interface for I take damage. Let's take damage and health. I'll move it to its own file, just Alt-Enter, and move to file. Now make sure you don't hit remove unused interface, because that would just destroy it and delete your code. Then I'm going to copy this interface right here, the I take damage, and let's go just drop that onto our entity original. Very important step that's easy to forget if you don't auto-generate these things. So I've added it onto my entity, And the last step here is we need to make it so that our auto attack interface doesn't care about the target being an entity. It only cares about it being an I take damage. So we change that to I take damage, and I should be able to build. Just Control-Shift-B in Writer or F6. Oh, we have an error though, so let's take a look at it. The error here is that our target on the implementation doesn't match our I take damage. So I need to change this to be I take damage. And that's because we're implementing I auto attack, which requires a target of I take damage, and we had the wrong type there. So we just had to fix that. So now I think we're good. Let's build one more time. Oh, one last thing. So the transform. Our target, we need the transform for the position. So we have a couple options. We could wrap the position or something, or we can just add the transform to the interface. So I'll hit Alt-Enter and hit Create Property, and then that's going to create a transform on this interface, but we need to change it to actually be type of transform. And we only want this to be a getter, and then we'll have to add a using statement for using Unity Engine. So this is the same thing that we have on the iAuto attack. Because it's a mono behavior, it has the transform there already, and we need that transform just because we're looking at the position. Now, we might abstract that away. In fact, we probably would abstract that away so that the position is read internally by the class from the transform or whatever. But it also works fine to just add transform or game object or any other mono behavior property to your interface, and you'll be able to access it through the interface. So that should be about it. Now our test should just about run, except we haven't assigned our target. So we need to set up our target. So now we don't need an entity original. We'll take this to an I take damage, and we'll make a substitute for that as well. So we do substitute for I take damage. Now this might not make sense yet. If it doesn't, you're going to see what the benefit is in just a moment. We're going to be able to determine that our target actually took the damage because we're using these interfaces now. So we've set up a target as a substitute, and our target is going to return back that target instance. Now, what we can do is assert that the target, watch this, target.received.takeDamage, and we should receive it with any argument, but really the amount is going to be whatever our damage is. So let's set up a damage amount. We haven't done that yet. So on our owner.attackDamage, we want to make it .return. Oh, let's just return a 2. So it'll do 2 damage. So then down here, we can assert that the target received 2 damage. Now let's go run this test. So to run the test, we'll go over to Unity. We can run it from Writer, by the way, but most people aren't using Writer. So I'm going to go into Unity here. And to open up the test runner window that I have there, you go to Window, and then, General and Test Runner. There's no shortcut for it right now. And it'll pop out. I just had mine docked up here, so I'll redock it with the hierarchy. And the test that we want to run is waits for cooldown. I could run them all, but I just want to run the single one. Now, if you don't see anything here, just again, make sure that your test file is in an editor folder. I have editor tests and then my actual class. So let's run the selected test, and look at that. We got an error. So it says object reference not set to an instance of object. And right here it tells us that it's on line 32 of the auto attack controller. The nice thing in Writer, if you're able to run your unit tests in here, is that you'll actually see links. So I ran the same thing here, and we get the same error, and I can click on it and it'll take me directly to that line of code. So it's telling me that something is null here. And I know it's not my owner, right? The owner isn't null because I'm mocking that and injecting it in. What's actually null here, well, it could be the target, but the target is null, it would bomb out, right? So it's not that, it's the transform. So I wanted to show this because the first time I tried to do something like this, I ran into this exact issue and I got stuck for a while, and I was like, what can I do? You know, like I'm trying to get away from the transform, but I still have it there, and I can't pull it out completely. The movement and everything is still controlled by that, and it's just not part of the layer that I can rip out, but I still want to be able to test that distances work, and I don't want to create the objects. I don't want to do runtime tests or play mode tests. So what can I do? Instead of mocking out, or putting in the interface my transform, one option, and this is one that I've used and it worked great before, so I'm going to show it, is to just add in the part of the transform that I care about, and that's the position. So here, I'll put in a vector3 position with a public getter, and notice that it's a capital P. And I'm going to delete the transform part. So just shift and delete while I'm on that row, wipes the whole thing out. Then I'll hit Control Shift B, which is my build hotkey. Again, that's a F6 in Visual Studio by default, at least with the C# defaults. Whatever your build hotkey is, figure it out, use it all the time because it's just like a save all and a compilation check. It's how I test and basically how I save all my files. So there we go. We've got a build, it ran and it failed because our entity doesn't implement iAutoAttack.position. Exactly what I expected. So that just means we need to implement it. And you might think, well, how do we implement position? We're going to just add a getter and a setter? Nope. We're going to do this. We'll say public vector3 position, capital P, and equals greater than transform.position. This is actually, here, let me rewrite it the other way. So if I hit Alt-Enter, I can change it to an explicit implement. Oh, no, not that one. To statement body. So this is essentially what I've written here. I don't really need that. But the shorthand version of it is this expression body. So it's the same as writing a getter and returning that. So trying to show that a lot so that people get really used to it. And we need to make this public. So there we go. We have an implementation of position that just returns transform.position. You might think like, okay, that doesn't help at all, right? But it actually does, because now if we go into our code where we deal with it, so let's just do build again, and we're going to get the error right where we need to change our code. But if we go to the code that's doing these positional checks, instead of checking transform.position, let's zoom that in a little, we'll just check position. And then we do the same thing here. We get rid of the transform.position and just check position. Now, that means that we also need to fix this target. So let's go to the target. Target is an I take damage, and it was also implementing this transform. So we're just going to do the same thing. We're going to right here put vector3 position with a getter, because we don't care about the transform. We just want that position. And since our only implementation of that is in this entity original that already has the position, we don't really need to do anything for it. Just got to go right back into the auto attack controller one more time. Just double check that that's good. Yep. Looks like everything's fine. Now we can build, and we're almost there. Yeah, I said almost because there's still one more thing that we're going to need to do. Let's go in and try to run this test one more time and see what happens. So we hit run, and it passed. So the test is passing. Everything is looking good so far, right? But we're not completely testing it, right? We've checked that it ran once, but we're not checking that it actually waits for a cooldown. So here we're just asserting that ticking the first time works. What we want to do now is make sure that ticking a second time without time passing does not happen, does not make this get called again. So I'm going to copy my auto attack tick and just paste it right there. And then we want to assert that we did not receive. So I'm going to paste I copied and pasted line 28, the received, and we'll change this from received to did not receive. Oh, there we go. So now we want to assert that it didn't receive the same take damage call. So it received it the first time, but not the second time. So let's do that. And again, it's still not quite getting us there because we want to make sure that it does fire again on cooldown. But, oh, look at that. So we actually got an error here. It expected to receive no matching calls, but it actually received 2. So let's take a look at that and see why. So we called take damage, or we called the tick. The tick went in, determined we could attack. It did an attack, and then it, let's see, when it did the attack, it should have set the next attack time to time.time plus the owner.attack delay. Okay, so let's go back and look at our test. It's our attack delay. It's not set, so we need to actually give ourselves an attack delay too. So here we go. We'll paste this in with a delay. And again, give it maybe a 2-second delay. Now our test should pass, right? And you're going to find this a lot when you're setting up your unit tests, that sometimes you're doing a bit of discovery on what things are actually needed for a state to happen or a thing to happen. And it might seem kind of tedious and annoying, but you'll find that you start to learn a lot more about what's going on with the code and how things are interacting and working. So now we run it again, and it's saying that we expected no calls, but we received one. Oh, and I see it. I just misusing this right here. So what we really want to do is call the tick twice here and assert that we only received it once. So we want to put received in there once. We want the did not receive when we don't want to receive any at all. When we've actually received a count of them, we put in the number in the received parameter here. So parameter 1 is how many we expect to receive. So we should receive one of them at this point. In fact, we could even do it right here that we've received one, we tick again, and we assume that assert that we've still received just one. So now if I go back in and run, we should get a passing test, but we're going to want to do one more thing so that we can actually move time ahead and see how things work over time. There we go. We're passing. Really good. But now we want to maybe pass some time ahead, and that's a little bit hard to do with our current setup. So if we look at our auto attack controller and we look at our next attack time, we're using time.time and owner attack delay. And then here we're using time.time to check to see if it's less than that next attack time. The problem that we have is that our unit tests don't want to wait. So, I mean, we could sit here and sleep in our thing, right? Maybe we go thread.system.threading.thread.sleep and give it like a 3-second delay, 300 milliseconds, and then call tick again and assert that we received it twice. And I mean, technically this might work. I'm not even 100% sure it would work, but it has a huge downside of we'd have a unit test that now takes 3 seconds. And in general, we want all of our tests to run way faster than 3 seconds combined. Now, there's also the issue that this won't really work. So if you sleep, your datetime.now values will get updated, but time.delta time or time.time doesn't actually move forward when we're sleeping in a unit test running those tests. So this isn't going to work no matter what. It might seem like a nice, easy way to do it, but it's just not going to happen. So we'll delete that, and I'm going to show you the way that I like to do it, or the way that I've done it before in a bunch of games. And that is to implement my own time layer, or wrap the time. And I've got an implementation of that right here. So if I just search for JSON time, let's see. There you go. You'll see a nice, simple, static class. Let's zoom that up and make it nice and big. So we have a class named something time. It's usually something like the project name or the game name is time. I've got a static float for an amount of seconds to move forward, a reset to reset that forward to 0. It's going to default to 0. And then these are the two important parts, really. The move forward for unit test, a number of seconds, which just increments forward some amount. And then the static float time. So here we just return time.time plus the forward amount. So this allows me to just set time forward in my tests and then reset it and kind of bounce it around as I want. But for this to work, I need to actually use this time. So I go into my auto attack controller, and instead of time.time, I just use JSON time.time. And I find the other spot right here and go JSON time.time. Now if I go back over to my test, when I want to move time forward, what I can do is just say JSON time dot move forward for unit test, 2 seconds. And then I can run my test. Everything should just work. And the magic will have happened, right? Let's see. So we run the test, and it waits, and it passes. There we go. So now you hopefully get an idea of how this works, and of course this little trick of being able to inject in your own time really, really helps, and it makes it so that you can test these things that run over time very easily. And it's really easy as long as you follow the same pattern that matches time.time, and maybe add in a delta time or whatever things that you might need to test against. It gets very easy to just swap it in and out, and it won't make a difference. So I don't know if there's much more to show here. The whole point of this, again, was just to show how to peel these things away and make them testable, make your little chunks of code that are likely to break a little bit easier to test, a lot easier to automate the testing for, and a bit easier to understand by peeling them out of big classes. Again, if your entity was as tiny as the one that we had there, it's probably completely pointless. But if you have a real game with big classes and big stuff there, or you're trying to just refactor it down and maybe shrink something, maybe you got classes that you feel are too large or too out of control or too hard to work with, it's a really easy way to kind of start resolving that and fix it up. Just start peeling things apart, make them testable, and get tests on them, and again, have slightly cleaner and more fun to work with code. Anyway, if you have questions about this or suggestions, please drop them down below. And again, most importantly, if you like this and came all the way to the end, just please share it, put it up, hit the little share button, make it go to Facebook or wherever, because YouTube really likes that. That helps everybody. And then I make more videos, and it's all cool stuff. All right. Anyway, thanks again for watching. Again, questions just down below, and